Welcome back. In this lesson, we're going to be finishing off Chapter 12. And for the rest of this chapter, what we're going to do is kind of investigate some different phenomenon that these waves show us. We've been spending the last two times talking about waves and their different properties. Well, now we're going to investigate some phenomenon that comes from having these waves. And the first thing we're going to look at is superposition or interference. And this stems from the fact that waves carry energy. Remember, we've written this down before, but it's so important. I'm going to write it again. Waves carry energy, and only energy, not mass, energy. And as such, something unique happens when two waves occupy the same spot at the same time. Now, in terms of like matter, you'd think, well, two things can't be at the same spot at the same time. Okay, if I tell somebody to sit in the chair and I tell somebody else, no, I want you to sit in the chair, they both can't sit there at the same time. They can't be at the same spot at the same time. This is not true for waves. And that's because since waves carry energy, they can both act on and use that energy on that object. So if we look at transverse waves, and so if we talk about, like, if this is my undisturbed medium, and if I send in a crest that's traveling along in this direction, and then I send in on this side another crest, but so they're going to collide. We got to remember what waves do. Waves exert the energy on that medium. And so what the blue one's doing is it's pushing that undisturbed medium up that distance. The purple one is also pushing it up and going on that distance. So that when they get to the same spot, and I'll draw that here, what you're going to have is you're going to have the blue one and the purple one stack on top of each other. So initially, the blue one pushes it up, and then the purple one pushes up its amount too. So what you end up getting is a really big crest in that case. This is what's called constructive interference. In this situation, you have two crests acting on the same spot, and what you end up getting is a really big crest. If you had two troughs acting in the same spot, you would get a really big trough. And so with constructive interference, and I'll highlight that, with constructive interference, this occurs when similar parts of the wave combine. And so you end up getting a bigger part of that. And I'll show you a couple examples of that here in a second. But the other type I want to talk about is called destructive interference. And here's kind of a step 1, 2, 3, 4, or A, B, C, D as it's happening. But you can see in this case, now we have a crest coming in and a trough coming in. So what happens at B is they start to combine. So part A, the crest on the left, is trying to push that rope up. Its energy is there to push that rope up. But the trough on the right-hand side is there to try and pull that rope down. And so what happens at part C is that they try and cancel each other out. Now in this case, since the crest was bigger than the trough, you end up getting just a smaller crest. And so it's not as big as the one on the left, but it's not as small as the one on the right either. So, and what happens here, and this is kind of the other neat point, I forgot to mention this in the other one, but after these waves pass by each other, they are completely undisturbed. The waves interfere. And then continue on. So this makes it different too than if you talk about two objects. If two objects come in and collide, those two objects are going to bounce off each other. We saw that in our law of conservation momentum lab. We took the two cars, they hit, they bounced off. Here, these waves come in, they combine, and then they continue on. Then continue. I didn't spell continue right. Hang on. Come back and fix that. And then continue. Okay. So I don't know, I was thinking I was writing that. So let me give you an animation. Let me show you this. Okay. So I kind of brought this one up, and not this one right here, but of some wave interference. So if I take a look at this particular animation, slide it up just a touch. Okay. What I've got, if it plays, is I have two waves coming in. I have a circular wave and I have a rectangular wave. Now when they combine, they try and push. They're both pushing it up. One in a circular way and one in a rectangular wave, but they combine to make that really big wave. And you can see the two different styles of waves coming together to give you that weird combination. as it comes up. But it eventually occurs because one's pushing up, the other one's pushing up in the same form. Now, let me go back, and I'll show you number 2. And this one looks a little bit better because these are sinusoidal. But as these come in, now we have a crest and trough meet. They're going to cancel each other out. There's our destructive. And then they crest and trough meet to make a really big crest and a really big trough. And so what you're seeing here is you're seeing, and I'll animate it as we go through, here is going to be destructive interference, constructive interference, and then destructive interference again. So as those 2 waves pass by each other, I am getting both constructive and destructive interference. So you can see this as it goes through. And I'll show these a little bit more tomorrow. And also I'll give you some animation links. You can go and play with this. You can actually do this step by step as well and actually design your own waves. So let me go back to the notes. Now, as I showed you in that last animation, you saw a wave that was repeatedly constructively, destructively, constructively interfering with each other back and forth as those 2 waves pass by. Now, if you have many waves passing each other by, you can get what's called an interference pattern. I want to show you one more animation of this, but basically it's going to look like this, and I'll come back to this slide in a second. But if I come back and I just want to show a 2-source interference pattern, this is an interactive demo, and let me show you here. What you've got is you have 2 sources, okay? Those circles down at the bottom are your 2 sources. And if you look, and it's a little bit trippy, but if you look at it, you can see those circles. If you focus on one individual circle, they're going outward away from the source. Well, what ends up happening is where the blue lines meet, you are getting constructive interference. And then where the black meets in between, that's also constructive interference. And so you end up getting what's called an interference pattern. And so what's kind of cool about this is you have spots where you have constructive spots where you're going to be like, it's really big, and then destructive where they're going to cancel each other out. And so if I go back to the notes, you can kind of see that. Let me zoom this in. This is kind of the same thing, but it's a still shot. This right here is a spot of constructive interference. Those waves are meeting. And they're making really big waves. Right next to it, and I'll put this in purple, this line right here, this is a spot of destructive. And I'm going to have to go to black to red stuff. Nope, not black. Black's going to be a bad color. Orange? Yeah, red. Destructive interference. And so these actually have names. The destructive interference spot, that's actually called a nodal line. And we'll talk about this later on when we get to sound as well. A nodal line. And it's a spot where there is no wave there. The constructive is the opposite of that, so we name it as an anti-nodal line. And that's a spot of constructive interference. And what's kind of neat is you can do this with water waves and get really, really big water waves or spots where there's none. You can also do this later on, we'll talk about with sound, where if you're standing in one spot, the sound appears to be really, really loud, and you take a couple steps over, and now you don't hear hardly anything at all because it cancels out because it's a destructive interference. But we'll examine this a little bit more, but I just want to show you, these are what are called interference patterns, and you can get these in water, sound, any other type of ways we talk about. Okay, and I'll show you the app that we can play with this too. All right, now the next thing I want to talk about is reflection. And now pretty much everybody's known about reflection. If you've dealt with a mirror, you know about reflection. But we're just going to draw it up. If this is my obstacle, or if this is my barrier, B-A-R-R-I-E-R, and I have waves that come in, and I'll make my red ones my incident waves, and I'm just going to draw them as the wave fronts. Okay, so these red lines are my wave fronts. When the wave front hits, my barrier interacts with that matter, and what's going to happen is it's going to bounce off, and I'll put that in green. So when this one hits, it's going to bounce off. Bounce off. And all of a sudden, now this sucker is going to come off like that. And so these red ones are my incident waves. They're the ones that are coming in. And it's almost easier to draw this as a ray. Remember our previous discussion a couple lessons ago, we said, hey, you could draw a ray that'll show, and I want this to be in orange, a ray that will show the direction of my wave motion. And so this can kind of be my incident ray. My green ones coming off, those are my reflected wave fronts. And I can also draw that as a ray, and I'll put that in purple. That comes off like this. And so that is my reflected ray. And what's kind of neat is we actually have a law of reflection here, which we'll talk about later on. But it turns out that the angle you come in at is exactly equal to the angle that you leave at. And so it almost becomes a law of reflection, which we'll talk about more when we get to light. But basically, I can tell you this right now, that your angle of incidence, which we'll call theta sub I, must be equal to the angle of reflection, which is theta sub R. Okay? So that's going to be our law of reflection. And I drew it kind of perpendicular. It's not always perpendicular. It depends. But the angle that it comes in at has to be equal to the angle that it leaves at. Now, the other thing, too, is that when these waves hit this barrier, something happens to them. If they hit a harder boundary, so like they hit into a wall or something like that, the wave will actually invert after reflection. So if it comes in as a crest, it'll leave as a trough. And I'm going to show you that in an animation tomorrow, okay? What it looks like if it bounces off a hard barrier and what happens if it bounces off a softer barrier. And so that goes back and forth. I'll show you that in the animation. But the next thing I'm going to talk about is a standing wave, because a standing wave occurs when you have that interference combined with reflection. And I'm going to show that to you in this animation right here. Not this one. This one. And so if I press play, what I have here is I have two waves. I have a green wave that is traveling to the right. I have a blue wave which is traveling to the left. And what's happening is you can think of there's something over here on the right that's bouncing off and coming back. But what happens after that is that you have repeated interference, both constructive and destructive. The yellow line here is actually the combination of those waves. And you can see that there are spots, and I'm going to pause this right there. There are spots right here where the yellow line is really high. That's when your blue and green are almost, they will be here in a second, constructive interfering, making a really big wave. And then down here, you have a really small wave. But there's also spots, if I continue on, stop right there. So close. Let me try that again. Right there. Pretty close. There's also spots that they will completely destructively interfere. And what it ends up looking is, even though the blue and the green are moving in opposite direction, that yellow line appears as though it's continuously it's going up and down, but it's standing still. It looks like a wave that's not moving at all. So I'll demonstrate this for you tomorrow as well. So let me pause this and we'll get back into the notes. So that's a standing wave. Now, the last two things we're going to talk about, the last two things are what happens when when waves change speed or waves bend. Okay? And actually the first one is that the waves are going to change speed and bend. And this occurs when a wave goes from one material into another. Okay? I've got an example. You probably have seen this or seen this before. When you have a straw or a pencil put into water, it looks like it's broke. It looks like it's bent. Okay? What's happening here is that when this wave comes in, it's coming in, and as it changes speed, that ray will actually begin to bend, and it's going to cause a change in the direction of the wave. And so you can say refraction is a change in the direction of the wave. Due to a change in speed. Actually, change in medium and change in speed. And again, we'll investigate this a lot more, especially when we get to light. The last one I want to talk about is that sometimes waves will bend even when there's not a change in direction or a change in speed. And that's what's called diffraction. Diffraction occurs when a wave bends when it goes through a slit or around a corner. And this is actually, you can see a natural wave pool kind of formed here in this picture where the waves come in and then they bend by going, and when they bend is they come out. Now, this is part of the reason why you can hear people around corners as well, because that wave will bend. And so this is probably the best diagram for it. But notice here, diffraction, the wave bends around a corner. So no change in speed. Or medium. And really, my goal here was just to try to introduce you to the terms. We will investigate these a lot more when we get into sound, and more especially when we get to light. So today was just about introducing the terms and getting you familiar with these different things. So we'll end here. So everybody have a great day. We'll see you later. Bye.